Good morning. Welcome. My name is Dan Abel, and I work for Pleo. Pleo is a spend management platform that makes expenses and bookkeeping simple. We have an Odoo integration. If you Google Pleo and Odoo, you'll find that. Advert over. Let's talk about me and then talk about what we're going to talk about. I've been working with software for more than 30 years. I've seen many code bases, helped many teams and organizations, solved lots of problems. And today I want to talk about one way I've solved problems. I'm going to talk about the challenges of navigating software systems and large sprawling code bases, introduce the power of maps as a tool to help us with this, and show you how to quickly build maps of your code, your services and systems to start solving problems and talking together to manage risk better. So I live in a microservices-oriented world. You may not. Mapping out your code, your systems, still valid. Stick around. You know, it applies to any sort of code, just as sometimes I think in microservices. So back in ancient times, the old cartographers placed mythical creatures on maps to represent real dangers. Sometimes they were placed to advise caution or recommend avoidance. Sometimes they were placed in empty areas that no one knew about. Pirate stories, maybe you're watching pirate films, contain similar maps: dangerous beasts, quicksand, tricksy routes to buried treasure. I like these metaphors, they're fun, and they're great to get a communal view of where code gives us bad feelings or where things are not going to work very well, even if the team doesn't know why. So as software engineers, we travel out. We go and make code changes. We often get into unexpected situations, or we have to step into infrequently traveled waters and work out how to navigate through them. These troubles can appear unexpectedly when we're making changes, running our tests, but much, much worse, they can happen when our customers start to use what we've built. So managing and navigating code is hard. Why is that? So I'm going to tiny bit of audience interaction. Everyone just puts their hand up so I can see you're awake. Thank you so much. Now, the people who write code, put your hand up if your code sucks. Thank you. Now, put your hand up if you think the code that you maintain but don't write sucks. Yeah, other people, the problem, right? So Claude AI and I collaborate in a haiku. Maybe that resonates with you in your daily life. Engineers deploy, unforeseen complications arise from small changes. I have a shorter version. All code bases suck. All code is a bit bad when you want to change it. Code is complex. Code demands comprehension. We climb into someone else's framing of the problem they were solving and their solution to it. It's written to do a job, and sometimes it's not perfectly clear or fault-free, especially when we need to change what it does, especially when it's not your code. All engineers have days when all we can do is get the thing working and into our customers' hands. We may not be able to tell the story of how and why it works. We may not be able to explain how and why it works. It's just about working. It's going to help the customer. Let's ship it. Sometimes the engineer signals this in the code, but not always. Discovery usually happens after the planning, after commitments are made, and maybe after the code is written. But it happens late in our cycles. So that fella is Dave Farley. Dave Farley writes and talks super well on code quality management. So I'm talking about mapping. There's lots more we can do to improve our ability to deal with change. If you want to know more, it's well worth checking out his talks and books. So I saw this slide last week and thought, that's it. That's the thing I need on my deck. The quality of a system is defined by our ability to change it. So who agrees with that? Is that the quality we look for? Maybe. Yeah, there's other qualities. Quality sometimes in our users' hands getting stuff done. But the user's getting stuff done, and we change the code, and it doesn't work anymore. They can't get their stuff done. So I think it's as important a quality as the stuff that sits in our users' hands. So you and your ability to change code is key. Changes what we do. And safe. So for me, safe, effective, and efficient change is an important measure of quality. So what do we do to help each other as engineers? How do we communicate these imperfections and these failures to frame our solutions clearly? We try and warn folk, just like the old maps did. That is a copy of a comment in some open source code from 2012 with a PHP transpiler just before the code does something really clever, really long, and really scary with images. There are thousands and thousands of comments like this in the code around us. I did a GitHub search for that phrase, and it comes up thousands and thousands of times. We try and tell people, whoa, this is a bit scary. But maybe it's too late. We talk about the code we own and manage. Where we find dragons, we find low quality. No matter how good the quality is, our ability to change is low where the dragons be. So ideally, we should fix problems like this. Is that possible? Can we go in our code base and fix every time there's a dragon? Will we get anything else done? Not really. But forewarned is useful. So what do we do? I asked myself that question. If we could know sooner and act accordingly when we're planning a change, could we raise the team's ability to make good, safe changes? Could we know we need to improve the tests around that code before we make changes to it? Could we know we need to mob code, get together as a group and solve that before we start individually assigning tasks? Can we be much better prepared to improve what we have? What if we can make the dragons more visible, more well-known? And what if we can signpost not just the dragons, but the treasure, the buried treasure too? Those bits of the code base that are really good, high quality, that we should aspire to. And that's my solution, code-based maps. Teams having focused conversations around the hidden dragons and buried treasure in their code base, turning those into maps of code and systems we can all use, highlighting the risky, the scary, the unpredictable, and what's great, and what perhaps might create a better future. But why maps? Let me talk about maps for a minute or two. Forgive me for this, map geekiness, and describe when and why they're powerful tools. Maps are tools that help us, they guide us. They should be opinionated and serve a clear purpose. More than that, great maps lie to bring a useful truth to life. And you need to remember this when you bring your code-based maps, that your map's not supposed to be a perfect truth. It's a tool to help you get your job done. So, back in the 1600s, a cartographer called Gerardus Mercator created a very revolutionary new map based on a cylindrical projection of the globe. This map simplified nautical navigation, allowing courses that followed straight lines. You could draw a straight line on a map, and then you could plot that straight line. But it also massively distorted the truth of the size of countries. And when applied to world maps, it inflates the size of some of the lands. The further away the land is from the equator, the bigger they appear than they are. But that's okay. For the job that map had to do, it did a really good job. For the job it didn't have to do, which is what's the biggest country, it was rubbish. Now you might recognize these two maps. And I'd like to ask yourself, these are Brussels Metro maps. Maybe you use it to help you get here today. Maybe we'll use it to help you get somewhere tonight to find a really good beer, because there's some really good beers in Brussels. Which one is more accurate? Which one is more useful? Which one's going to get you where you need to be? So, again, like the other map, this distorts reality and ignores some facts to be really useful at the job of getting you somewhere. It gives clarity to something important but complex. It's better for any map you create to be focused on a few facets of the world than to try and convey everything. And this is important in your map building. So if great maps are tools, what might be a useful map of some software services and libraries look like? This is a sample, what I call a pirate map. It looks nothing like your code, nothing like your app, nothing like your services. There's no network topology. It's pretty basic. But what it does do is provide a platform to surface information, helping you show the most important things you need to know when you're going to change your system. Maybe a map like this, or a map you can create, would help you navigate, just like those old maps help sailors, and just like the Metro map will help you navigate a new city. So I've used these in multiple teams in different ways, and you'll see that in a minute. Collaborating, exploring what each team knew about the systems, what they learned on the way, discovering how they can navigate better, what they knew least about, what always breaks, what's not quite right, and what parts are good examples and patterns. So let me see in 5 minutes if I can tell you how to build a map. I start with context. I like to work from the outside in and build the business context these services and code are sitting in. Often my framing boxes, my continents and coastlines summarizing this business context. I ask, what does the team own? And explore the jobs and services and code that does work for the business. Now this isn't far from a system context diagram from the C4 diagram model, but we're going to pivot away from that in a minute. But if you've got a C4 diagram, the top level ones, they're probably a great place to start. And then I asked the group, what does the work? And adding smaller units. These are often the services or the chunks of code inside a large code base themselves. I'll ask, why is it there? What's it for? What's it do? I get more context, and I can lead to adjustments in the map. I start squidging the layout, and I ask, what's big, what's small? This allows me to start shaping the bigger lumps of code and behavior in the map. Size often relates to complexity, but not always. I might ask, what's really complex? What's hard to ship or change? I want to find out, if I can, and capture that too. And then I ask, where are the tests you trust? I come from a test-oriented background. If there's no test in the code, there's very little I can do. So where are the tests that trust that I can make a change, the test pass, I can ship to customers? I also ask, what code set's a good example? So I'm starting to add in knowledge. Beth said she's never going to touch that. Someone else wonders, why are there so many services just transform an image? This stuff, it's just confusing. There's a great big mothership. That's probably doing a hell of a lot. What can we do to indicate those things? Finally, I want to add the tacit knowledge, the thing that the team understands. I say, what's critical to know? What would you tell someone if they were going to make a change? What would go, oh no, don't do that, or yeah, you'll be fine. And really make sure the depth of those conversations that are raised are captured. You can see the mothership service, as we thought, it does way too much. It's not clear how it does it. There's a global issue. Tests fail for no reason everywhere, so there's something wrong with the test framework. Over there, the image transform, why is it not one service? So you can see we've got some gold. The main admin tool, new code, the team loves it, really pleased. They've got a standard library. So they can think about how they make the changes. So that's a really quick version of how to build a map. And I want to show you some I've built with teams and show how they've used them. So here's a partial capture of a map set in the authorization and authentication space. I was working with a team who inherited some set of services. They need to own them. We're forming a new security team, so they got the security bits that belong to the company. So we mapped it out together. We need to work out how they're going to navigate what inherited. Could they make it more secure? How could they own this? How would they know if someone had penetrated the system? So some of the questions here were mostly code-based, but some of them were probably security-based too. Certainly the team used that and found some risk, removed risk, found some complicated code, removed them. It was certainly a tool that helped them. Here's a map produced for a large set of services for a science publishing company. This is 5 teams coming together and talking about what's good and bad about their world. You can see the gold, the dragons, some critical areas called out risks and warnings. Now that might be hard to see, so it's a clean version. It's not as pretty, doesn't have the dragons and things on, but maybe it's clearer. Very hard to tell from where I'm standing which one's clear on the screen. So let's talk about how it's helped. I've told you how I built them, why they're important, but it's really clear for you to be motivated to try and do this, say how they've helped. I've found that teams gain massive value from just sharing and building a map together. Those conversations, oh, do you not know that? Oh, this bit's really good over here. Oh, that bit, never change that bit in ship, always go and talk to George. This collective understanding rises in the team massively, and their ability to all make safe change grows, and the ability to navigate and plan together. Beyond that, I've seen these maps used to look forward to de-risk and guide future work. This is a shabby photograph, apologies, of a map being used. They've printed out the map, and they're planning the impact of a large piece of work. And they're going, well, it's going to impact this bit, this bit, this bit, this bit. Oh, it's going in the scary bit. Maybe we have to plan a month to improve that first, so we don't have that outage like we had last time. This allows the team to predict high-risk changes and look to leverage the good code and be predictable in their delivery dates. So well beyond just estimating a load of stories, they're actually looking at what they actually hold and how hard it is to change. Here's a photograph of a paper mapping process back when we generally met with each other rather than remotely over a mirror board. And this is for a dating site. Team that held it did a lot of analysis of which parts of that dating site were working, which were not working. And that proved really useful. When it was handed over to a new team, it got offshored. The new team take ownership of the product, to take their map and turn it in part of their onboarding guide to take ownership of their new product successfully. So, talking and sharing the challenges together is really useful. Knowing when new work could be tough, when you're planning new work, is really good. Identifying code as a good standard, that's super useful. And then maybe planning technical debt pay down. You know, when someone says, we need to pay tech debt off. Why? Well, look at this bit here. It's always a problem. It's useful. So my pirate maps are a tool for understanding the quality of what you own and steward, how a change you need to make might land. They're a placeholder and a signal for a deeper conversation about quality and risk. And I'd like you to challenge yourself a second. Ask yourself what your team's map would look like, how a team map would help you with the problems you have right now. And my suggestion is, if you can see insight in that, ask yourself, can you book a 2-hour mapping session, gather your team, take that 5-minute guide I've given you, it's written up on this URL, and run the team through it, and be open. Let them talk to each other. There's much value in that conversation, as much as the map that gets produced. Listen, inquire, capture, get them talking, and see what you learn. So if I'm lucky, this is going to turn into a question. I've got my test question there, apologies. But if you write your questions down, the QR code there, you should be able to ask me questions and we can talk together.
Or is it like?
Oh, if you can raise it, yeah. But and if nobody has any questions, then thank you very much for coming to this talk. I should go. Thank you. Got a photograph of my mum.